Today we are going to cover the Poisson's ratio, and to demonstrate the experiment we will be taking a specimen of aluminum. It's a similar kind of aluminum sample that you have tested for the tension test. It's T66061, and you can see this is a flat grip. I will show the cross-sectional dimensions in a minute. Now let me talk about the specimen geometry. So this is a flat specimen, and you can see we have a very larger dimension in the two grips, and inside the testing where we will be taking the data, you have a smaller diameter, and the change from the larger to the smaller is very smooth, so that we can have a very smooth stress distribution on the testing section. Okay, so the way we now, to record the strains, we're not going to use the extensometer today. Rather, we're going to use something called a strain gauge. Okay, so we have strain gauge. That purpose is to record the strains at whatever directions. So let's say now we want to find out for our axial direction and also the transverse direction. So we have to have two strain gauge, one in the axial direction, which in this case you can call as the 90 degree, and another one that is in the 0 degree, we can call it as the transverse strain gauge. Now strain gauge is nothing but a combination of wires, look very thin wire that is placed in a very small amount of space, and you put that gauge on the surface of the specimen, so that when the specimen is pulled, right, the wire inside the strain gauge is gonna fill the pull. So by recording the change in the length of the wire, you record the change in the resistance and convert into a strain inside the testing section. Okay, so let's quickly measure the width. So this is 0.5 and thickness should be same. This is 0.25, so it's actually a 0.5 by 0.25 specimen. Okay, and it's a flat end specimen, so we have to use these flat grips. Okay, so you have two grip, both the top and bottom is flat. So let's put the specimen there, and then we will see how to get the strains. Let's bring it down before closing, so you can use the handheld device, that remote. Just bring it down. Alright, now before closing the top section, so that when I close, it will induce some sort of contact load, that means some sort of contact stress, some sort of contact strain. So before doing that, let me go and pull up the software. So we'll be using the same TW Elite software, but in this case today we're not going to use the any tension test profile or any other test profiles. Rather, we'll be doing the test manually. So you can check any of the test profiles. We just need the load window. Okay, so go to the file section, click open test, and anyone, let's pull up the tension test, but we're not going to use the machine to do the work. Rather, we'll be doing manually. Okay, so what we're interested here is the load window. Okay, so we'll be putting different kinds of loads at a different from starting from 0 pound, let's say 10, 100 pounds, 200 pounds. So that way we keep changing the load and record the corresponding strains both from the axial and transverse. Okay, so let's make the load 0. So I'm going to start from 0, so you can hit the 0 signal. It's now showing 0. And let's close the top end. You have to be a little bit concerned about whether there is any sort of bending or not. It looks pretty flat, so that should be okay. And as you can see, we have some sort of preload, right? 492, that is a preload because of the contact of these two grips. We're not yet making it 0. Now let's talk about the way we record the strain. So we have 2 strain gauge. So to record the data from those 2 gauges, we need some sort of instrumentation called strain indicator. So the instrument you can see here, this blue box, that is a strain indicator, and this works only when we connect our gauges to the channels. So this indicator has, you can see, 4 channels, channel 1, 2, 3 and 4. So that means it can handle 4 strain gauge at a time. Now in our case, for the Poisson's ratio experiment, we have 2 strain gauge, one in the 0, another in the 90. So we can use 2 channels. Alright, so we are going to connect the gauges to the strain indicator now. So the red wire, as we have said, red is going to be P positive. So this is, by the way, my it should be the first one. So that is the axial gauge. Okay, so axial transverse axial gauge, I'm putting it on the red to the P positive, then black, just pull it over. The next red is going to your D minus, just put it there, you close, and once this connection is done, then you should get something on the display. Okay, so if you get something that may not be the right data, but it will tell you, okay, the connection is working perfect. So similarly we will connect the second gauge. Let's use channel number 2. So you put the red, then your black, and then the white. You must check whether the wires are going inside so that you can get the proper connection. So looks like I'm a little bit struggling on that. Okay, so I have both the gauges connected. So the channel number 1 here, so you hit the bridge button. Alright, so if I hit, I have channel 1 as quarter, channel 2 also quarter. So if this is not there, you can go back and forth and bring your gauge type whatever you want. Alright, so once you are happy with the gauge, you can come out of that, hit the menu. The next, you check the gauge factor. So each gauge comes with a different gauge factor. For our Poisson's ratio gauge, we are using a gauge factor that is 2.145, and that data should be provided by the manufacturer. Alright, so in your lab handout, you should get a 1 page dedicated for the strain gauges, and there it is written as gauge factor K is 2.145. So let's hit K, and we're going to check what is our gauge factor in the machine. If not, we have to set it accordingly. So right now, let's see what the display shows. It shows channel 2 unit micro strain and gauge factor 2.145. So this is fine. Okay, let's check the first one. So you can go up, and let's go back. So channel 1, it's showing micro strain and gauge factor 2.145. So channel 1 is okay, channel 2 is also okay. If you're happy with that, you hit the menu. Alright, next thing, we want to start everything from 0. So whatever load I have due to this contact stress and whatever strain, we want to remove all those things and start from 0 load and 0 strain. So hit the balance. Okay, so if you hit balance, it will try to balance only those channels where you have connections. So it now tells cannot balance channel 3 and 4 because we don't have anything connected on those 2 channels. Once this is balanced, channel number 1 and 2, to record this setting, you hit the record. Alright, so we have our 0 strain scenario. Machine is okay to record the strain, and if you look into the lab handout, it says you start from 0 pound, then 100 pound, 200 pounds, that way you go maximum 1000 pound, and record whatever strain is happening for all the cases from both the two gauges, and then again come back to 0. Alright, so let's zero the signal. So we are just neglecting this effect for this case only. We want to increase our load from 0 pound and use the manual, this handheld device. Okay, so it's better, and you must, it's not better, you must use the fine tuner because it builds up load very quickly. So use the fine tuner, increase the load and get the strains from this two. So I will show let's say for 200 pounds. So I'm going at fine tuning maximum 200 pounds and see what strain we get. Okay, so I use the fine tuner, the load is showing about 200, it's 199. Let's come back and see what strain we get. So channel number 1 is our axial gauge, so you should get positive strain. So I'm getting positive 142, and this is in micro strain. Channel number 2, this is a transverse gauge, so the width is shrinking. We should have a negative strain, right? And that's what we're getting here. Channel number 2 is showing negative 44 micro strain. Alright, so that way, let's take another data so that we can say it's linear or not. Let's go to 400. So I'm going to maximum 400 and check our strain reading again. So at 400 pounds I'm getting axial 285 microstrain and transverse negative 89 microstrain. So the things are linear, so I'm having a linear change in load and I'm having a linear change in strain also. So that way you have to increase maximum 1000 pound and again come down to 0. Since we're not crossing the elastic limit, so all the loads, if I take all the loads back to 0, our strain should also come back to 0 due to the elasticity. So let's now come back to 0 from where I am right now. So I'm taking all the loads back, so it's roughly 0, and let's see what is the status of our strain now. So I have now 0 pound loads. I took all the loads back, and what is the strain I have? You see, the channel number 1 is negative 3, channel number 2 is 1. So I had 0 0 when I started, and when I took all the loads back I have pretty much 0 strain. So this is perfectly linear behavior, and we have observed two different types of strains in two directions, one positive, one negative, and you can use the your handout to follow the steps how to find the Possion ratio, and a lot of things you can also get from the handout. Alright, so once everything is done, you can take the sample back, and that way the specimen will be over.